Today we're going to talk about solving radical equations when they're written in radical form. Our guideline steps are going to be to isolate the radical. We're going to raise both sides to the power of the index to undo the radical, solve for x, and then check for extraneous solutions. Sometimes with certain problems, you will have to repeat the process of isolating the radical and raising both sides to the power of the index to make sure you have no radicals left to solve the equation a few times. Extraneous solutions are answers you get using correct math that do not work when you substitute them back into the original equation. So it is so important anytime we're solving an equation that has to do with a radical that we're checking our work by substituting back in. So we'll start with a straightforward problem. We're going to isolate the radical by adding 5 to both sides, getting the square root of 3x plus 13 is equal to x plus 5. Those are not like terms. You can't add them together. It is what it is. Now we've talked about the square root here. It's the index of 2, even though you don't see a little 2 written in the index spot. It's assumed. So in order to undo this square root, we have to square both sides. Now remember, when you square x plus 5, you are actually doing x plus 5 times x plus 5. This is a topic that keeps coming up in Algebra 2, and we are continuously seeing that mistake from some of our students. So when you square a square root, the radicand falls out, leaving 3x plus 13 to be our left-hand side of the equation. When you square a binomial, you have to FOIL, getting x squared plus 10x plus 25. At this point, we have a quadratic equation. You should be pros at solving quadratic equations by now. We set the equation equal to 0. And our first attempt at solving a quadratic is factoring. This is factorable to x plus 4 times x plus 3, giving us x solutions of -4 and -3. Now we know some restrictions on our even roots is that you can't take a square root of a negative number and end up with a real number. When we're solving equations, we are looking for real solutions because the imaginary world doesn't really work when we get to like 4th root or 6th root or something higher. So we don't really worry about it anymore. We're kind of stepping away from the imaginary realm of things. Therefore, if you get a negative under an even indexed root, it's extraneous. So we got our two answers. We do have to check them. Our two answers were x equals -4 and x equals -3. Now you do have to show your check because we can't read your mind. We don't know if you checked it or not. So you have to write it on your paper. The first one we're going to check is -4. Substitute it back into your typed equation. It's important you substitute back into your typed equation because once you change the equation, you might be doing something that makes it work even when it's not supposed to. So I'm going to do a little bit of math as I substitute. Get -12 plus 13 right away. Square root of 1 minus 5 is -4. Once you get to a reasonable, like, yes, that is definitely true, you can stop writing your work and decide that, yeah, we found a solution to the problem. You do have to check all of the answers you come up with, so here's my check for x equals -3. Again, written down because we cannot read your minds. So both of our solutions do work in this problem, and we can comfortably say the solutions are -4 and -3. You will not get full credit if you do not show a written check. So when starting to solve this one, I noticed that it is a cube root, which is an odd index that takes away some of my restrictions on my solutions because we are allowed to have negative numbers under odd indexed radicals. So that's not something I need to be cautious about when I'm checking. The process to solving any radical equation is the same. You have to isolate the radical. I'm going to do that by dividing both sides by -5. So I get the cube root of r plus 19 is equal to -3. I'm not worried that I have a root equal to a -3 because the index is odd. It is possible that I have an output of a negative number from an odd root. So that's okay with me. To undo a cube root, I'd raise both sides to the index, which would mean raise it to the 3 on both sides, resulting in just the radicand from the root side, and -3 to the third is -27. You do have to have a reasonable amount of knowledge for your cubes and your fourths and your squares for this chapter. Isolate r by subtracting 19 on both sides. We find out that r is equal to -46. We do want to follow through and check our work. Plugging into the original equation, -46 plus 19 is -27. And then the cube root of -27 is -3. So I can comfortably say, yes, that solution works to this radical equation, and circle my final answer. This process of raising both sides to the index works for any index you see. It could be a fifth root, we'd raise both sides to the fifth. If it's a fourth root, raise both sides to the fourth. It works for any of the radicals we could be approached with. Sometimes we get an equation that has more than one radical. Most of the time, the radical has an index of 2 if they're going to give you more than one of them. We start by approaching it in the same manner and isolating one of the radicals. Now, in order to isolate a radical, you do have to move a radical and keep a radical on the other side. So I'm going to work with the equation square root of 5 minus x equals 1 plus the square root of x. It doesn't matter which radical you move. I made this decision to be dealing with positive numbers because you're less likely to make a mistake with positive numbers than negative numbers. But it really doesn't matter which radical you move to what side, as long as you're isolating one of them using appropriate math rules. To undo the radical that's isolated, I would have to square both sides. Again, when we square the right-hand side, we have to FOIL. So on our left-hand side, the radicand would fall out. Our right-hand side, after FOILing, we would get this. I still have a radical in there, so I'm going to have to go through the process of isolating the radical again. My first moves for that would be to subtract 1 from both sides and subtract x from both sides, resulting in this equation. Now I could divide both sides by 2. Everything's even, so I can divide the whole equation by 2 and wouldn't be dealing with any fractions. However, that's not always the case. We're not always going to be able to evenly divide by that coefficient. So I'm going to show you a method that'll work no matter what that coefficient of the square root is. Because the coefficient is being multiplied to the radical, we can just square from here to get rid of the radical. Again, it's raise each side to the index. The index is 2, so I'm raising both sides to the power 2. On your left-hand side, you absolutely have to FOIL that. And on the right-hand side, we're raising a product to a power. That means that the 2 is going to get squared and the root is going to get squared. So this is really times this. So the way you would do this is to square the coefficient, get 4, and then multiply the coefficient by the entire radicand. Now in this case, that's really only x, but sometimes we have more than one term in the radicand. Again, we're dealing with a quadratic equation. We're going to set it equal to 0, keep that x squared term positive, and attempt to factor. This equation is factorable. It factors into x minus 4 times x minus 1. Took out the GCF to make my life easier first. However, that's not necessarily my final answer. I do need to go back and check x equals 4 and x equals 1 to the original problem to see if it works. When I substitute that in, I'm going to get the square root of 1 minus the square root of 4. They're saying this should be equal to 1. Well, 1 minus 2 is not equal to 1. Therefore, x equals 4 has to be an extraneous solution and cannot be included in my final answer. I like to mark them down here and say, okay, that didn't work. This is extraneous to remind myself when I record my final answer. I also have to check x equals 1 because both of them could be extraneous. That has happened before. So if x is equal to 1, I get the square root of 4 minus the square root of 1 is equal to 1. That is 2 minus 1 equals 1. So x equals 1 is the answer to this problem. In the end, x equals 1 is the solution. Again, make sure you have those written checks and that you're substituting back into the original typed version, because the minute you make a change, you might have made a change that would make answers that are supposed to be extraneous work out.